Welcome back, 8th graders. We're going to complete activity 2.4, which starts on page M2-34 of your textbook, so please follow along. Just like in our last activity, you will need some patty paper or some sort of paper to trace on, so just make sure you have that with you. And let's go ahead and get started. So in this activity, we see that Jack and Jill are walking back home from the bus stop now, which is 30 yards from their house. They're walking at the same rate, 4 yards every 3 seconds. So now we're given the original graph that we were given back in activity 2.2, and now we have a graph that represents them walking home from the bus stop. So let's just look at both of these. Part A, does the situation represent a proportional or non-proportional relationship? And we're talking about the walking home one. So proportional or non-proportional. I notice that it is a line, it is linear, but it does not go through the origin. So it is not going to be proportional. Is the slope of the line positive or negative? So this was something that was introduced to us back in activity 2.2. Also, when they defined slope, if you need to, you can look back at those pages to help you answer this. Slope tells us the steepness and the direction that the line is going. So if the slope is positive, it moves up from left to right. If it's negative, it moves down. So this actually represents a positive slope. The one graph walking home from the bus stop represents a negative slope. All right. So now we're going to move on to page 35. We're going to compare, we're going to contrast the rate of change and the slope of each line. This is where we're going to use patty paper, so have some patty paper out. It says use patty paper to trace and create any right triangle that represents the rate of change or slope from the walking to the bus stop graph. So we're doing the walking to the bus stop graph. So I'm going to put my patty paper down here on the walking to the bus stop graph. And I'm going to start at the origin. So I'm going to put a point at the origin. And I'm going to find another lattice point here. I'm going to use this one right here. So this is 20 yards from home and 15 seconds. And then I'm going to draw my triangle based on those 2 points. All right, so there's my triangle, my right triangle that represents the rate of change or the slope. Now for part B, we're going to place this patty paper on the walking home graph. And it's asking, how can we transform the right triangle you drew on my patty paper to match the walking home one? Well, man, it's not even close here. No translation is going to do it. I guess I maybe could rotate it, but if I reflect it, look at that. My triangle fits right in there if I reflect it. So this is a reflection. It took a reflection to do that. So let's answer that. Reflection horizontally. Oh, horizontally. We'll transform the triangle to match the walking home graph. All right. Part C, slide the right triangle along the line of the walking home from the bus stop graph. So kind of like we did in activity 2.2, I believe. Kind of if we slide it, it looks like between any 2 points, this triangle has the same slope. So that the unit rate that this represents, or the rate, the slope that it represents, remains constant. So I notice the rate the triangle represents remains constant or the same between any 2 points on the walking home graph. Part D, what is the slope of the line in the walking home from the bus stop graph? Well, if I notice that the triangle matches, all it took was a reflection and it matches, then I know the steepness is really the same. It's just going a different direction. So if the steepness is the same, and I know that the original graph had a steepness of 4/3, that was the slope, then I know that the slope of the walking home graph must have that same steepness, but a different sign. So the slope, m, equals negative 4/3 for the walking home graph. And I'm going to explain that in words again. Like I said, the walking home graph has the same steepness, which we saw using the right triangle. However, the direction is the opposite. So therefore, the sign of slope has to be opposite the walking to the bus stop graph. Move that around a little bit so you can see it a little better. All right. Number 3, we're going to wrap this up. It says write an equation to represent Jack and Jill's walk home from the bus stop. Let y represent the distance from home and x represent the time spent walking. So we saw in our last activity that when a line does not go through the origin like this, then we have this form of an equation where m represents the slope and this b represents the amount of the translation up or down, the vertical translation. So in this case, we're not at the origin, it's translated up 30 units. And we know that the slope for m is negative 4/3. So our equation is going to be y equals negative 4/3 x plus 30. So here's our equation that represents Jack and Jill's walk home from the bus stop. How does the equation you wrote to represent Jack and Jill's walk home from the bus stop compare to the equation that represents their walk to the bus stop? That's question number 4. Their walk to the bus stop, so to the bus stop. I believe this was back in activity 2.2. 2.2, we had, 2.1 even. So 2.1, the very first thing we did, we saw that the equation was d equals 4/3 t. Instead of d and t, we could use y and x. Y equals 4/3 x. So home from the bus stop, we just got done writing it. Y equals negative 4/3 x plus 30. So how do they compare? Well, first of all, the slopes are opposites of each other. The slopes of the two equations are opposites. and the starting point for each equation is different. When they walk home from the bus stop, the starting point has been translated up 30 units. So now we've seen a negative slope and what that looks like. So a negative slope, again, just refresh, slope tells us direction and steepness. So positive slope goes up from left to right, negative slope goes down from left to right. The rate for the slope, the rate of change, tells us how steep the line is. The greater the slope, the greater the steepness of the line. So I hope that helps. Have a great day, everyone.